Welcome to the lecture Practical macOS 10 Insecurity. Security concepts, problems and exploits on your Mac. I'm Angelo Laub. I'm a student of physics, mathematics and astronomy in Bonn. And I'm a Mac user since 1995. And I really love Macs and I'm a Mac evangelist. And yeah, that's for my person. And the intentions of my lecture are: I want Macs to become even more secure. I want Apple to react appropriately on security threats. And I want to give you an overview on Mac security. I'm gonna talk about Mac OS 10 security concepts. I'm gonna present you some of the worst vulnerabilities and a few exploits. And I'm also going to tell you how you can secure your Mac from these exploits. Yeah, first of all, a few words about security concepts on Mac OS 10. First, what's good? No network services are listening by default, like it is, for example, on MS Windows. And the user is never logged in as root, which is still today with Windows XP is not the case on the Windows side. And macOS 10 is, since it's a Unix at heart, it relies on the strong Unix security and permissions model, and therefore malware, worms and viruses usually need some sort of privilege escalation exploit if they want to tamper with the system. Yeah, what's not so good in macOS 10? We all know macOS 10 is an open system at the core. Darwin is an open source project founded by Apple. And what's not so good is the closed source security components are buggy, like for example the admin framework. I'm going to tell you later what's bad about them. And the user can do almost anything without entering the password in the default install. And this is a pretty insecure default setting. Now let's see what vulnerabilities there are. First, vulnerability, system preferences. What is system preference? Of course, you all know the system preferences. It's a closed source software, and internally it relies on a setuid root helper tool. And in the default install, I already told you, many things can be done without a password. The user can start and stop services, can change power management settings, user interface settings, and so on. But the user can also add new users. This is not so bad. This is not a major fault. One could imagine it's very useful to add a normal user without entering the password. But the problem is you can also add admin users without further authentication. And with this you can get root within five seconds. That's no problem. And I've been told this still works in Tiger. And yeah, I'm going to show you a demo how this can even be exploited from remote, if you have a shell, of course. I have a little shell script which does this automatically. Hoppla. German keyboard. Okay, this shell script. This is actually an Apple script wrapped in shell. It will open system preferences. Oh, this is not what I intended. Mark, unfortunately this is a borrowed book, and the owner apparently, could you please, this is, okay, I'm going to show you on my book. Okay, I'm going to switch the books. For this one, I didn't notice. This was not the default install, yeah? This is now the default install, where this exploit still works. It's a little slow because it's Apple script, and it's a slow iBook. Now it's adding automatically, entering a user. And did you see? The radio button, allow a user to administer this computer, was checked, and it didn't ask me for a password. And now I'm getting a root shell. UID gleich 0, equals 0, 0. And now I can install rootkits, opener, weapon X, and so on. What's the question exactly? I didn't understand the question. Ah. That's me. Yes, it's the default Apple user. The default user that is created during the installation. No, it's not possible. It should be asking me for the password. This is like doing sudo on a Unix system without the password. This is something that should only work with sudo. Yeah. Where's Keynote? This is the wrong book. I'm going to switch the books again. Okay. Yeah, of course one can fix it, but you can enable the require password to unlock each secure system preference radio button in the security pane of the system preferences. But the point is, this is not the default setting. So I can walk to any Mac in its default install and get a root shell for free. And this is not okay. And I reported this bug to Apple in October. I sent them this small Apple script, and I told them that this can be fixed by enabling this security setting in the system preferences. And then they told me, you can enable the require password to unlock each secure system preferences checkbox, which can be found in the security preference pane. Note, after doing so, any user will have to provide the admin name and password in order to change settings, including accounts, which is the way it should be from the beginning. And so, of course, this was not a question I wanted to be answered. I was reporting a privilege escalation vulnerability. So I was pretty disappointed about this answer, so I wrote them again and clarified my statement. And this time they answered, "Thank you for the clarification. Please know that we have forwarded this information onto the appropriate engineering team for review." The year is now over, but it's still not fixed. And this was in October. Interestingly, this morning I got mail from Apple stating that, yeah, they're taking security seriously. I should wait for the next security update. I should not publish it, should not discuss it with anyone. But unfortunately, it's too late because it's already in the Congress proceedings. So they were a few days late with their mail.
It's all right, we won't tell.
Okay, be quiet. And also, there were enough security updates in the meantime. There were two major Panther updates and at least 2 security updates in the meantime. So they had lots of time to fix it. Okay, vulnerability number 2, bad installers and wrong permissions, I call it. So you have to know that there is a directory called in library startup items. Global startup items can be put in there, and they will be executed as root during the startup process. Unfortunately, this directory does not exist by default, so installers have to create it on their own. You know, many third-party installers are not so great with permissions, and many installers will create it with the wrong permissions, so that it will possibly be user or even world writable. So this means I can execute arbitrary code as root by putting it in this folder and simply restarting. And in my research for this lecture, I have seen many Macs with wrong permissions in the startup items folder, and yeah, it was pretty easy to exploit them. Just put anything in startup items and reboot. And
Will have permissions fix this problem?
this is my next slide is going to explain this. The question was whether fixed permissions will fix this problem. We all know the disk utility has the ability to repair permissions. Unfortunately, it doesn't do it. It will not fix the permissions of library startup items. And of course, this is a bug, because it should do it. So as a fix, in the meantime, I would suggest to put something like this in etc rc or daily as a workaround, or execute it from time to time by yourself. It will fix the permissions, and this hole is not exploitable anymore. Pardon? Yeah, you know, I tried. Yeah, the question was, there are more than one startup items folders. At the moment, I'm not sure which other one. System library startup items. Okay. Okay. Okay, so the permissions of system library startup items are fixed somehow. This directory already exists. Okay, I repeat, this is an Apple managed directory, so the problem does not exist for this directory. And so this will be enough to fix the hole. Initially I tried to change the permissions for the whole/library, but then isync, for example, wouldn't work anymore, because isync will put user-specific data to /library, which is no good as on a Unix system. Vulnerability number 3, clear text passwords in swap file, I call it. The problem lies in Apple's security framework, which is the closed admin framework I told you. It doesn't lock passwords in physical memory by using something like mlock, which is known under Unix. And so eventually, passwords will be written to swap in clear text. And there's a one-liner in shell which will print your passwords. And yeah, you can try this yourself, type strings and so on, and you will much likely see your password in clear text. Of course, you need root. You need sudo to read the swap file, but still it's no good on a system where you have multiple users and even multiple sudo users. You can always read the other users' passwords. File vault, yes, you can also decrypt file vault. But with file vault, there's yet another story, because when you set a master password for file vault, you can decrypt all file vault passwords with it. So
The problem really is that in macOS, the user password is the key to a firewall and the whole keychain which stores numerous passwords and even other secure data. And
Usually-
so you got the user password, you got everything.
yes. Yeah, usually the normal user login password, I repeat, is at the same time the password for the file vault and for the keychain. This is the normal case on macOS 10, which is also not a very good practice. I know that you can change the keychain password, but I'm not so sure whether you can set a different password for your file vault. Yeah, how can you fix this? In Panther, there is a way. You can find it on this website, but unfortunately it makes macOS 10 unstable. So the author reports that sometimes it crashes after 10 minutes or so. So this is not really a solution. The only solution at the moment is to wait for Tiger, the next release, and there you can encrypt your swap file. But it's not really a clean solution. The only clean solution would be to lock the passwords in physical memory. And of course, it breaks performance on systems. For example, I don't want to do video editing with enabled swap encryption. Not even on my G5. Yeah, vulnerability number 4, personal file sharing denial of service. Mac users all know personal file sharing. It's sort of the Mac equivalent to Samba on Windows. And it contains a guest account by default. And the bad thing is you cannot disable it in the system preferences. And yeah, the guest account has write access to a Dropbox. And unfortunately, there's no limit on the amount of data written to it. So the only limit is the hard disk. The sky is the limit, the hard disk is the limit. And so the attacker can fill up all disk space with bullshit. And as any Unix system, OS 10 will likely crash when it has no free swap space anymore or kill arbitrary processes. And of course, this is especially dangerous over gigabit Ethernet because it's very fast. And yeah, I've created a small demo for this. I call it Rendezvous. And yeah, let's see if it works here in this. Okay, Rendezvous. So here you can scan the Rendezvous network for Macs that have Apple file services enabled. Now this is my local computer, but it should now also get this one here, which is standing here, this iBook. I wonder why it doesn't find it. Yeah. I know. Yeah, it's a wireless network. Yeah, that's probably better. I don't need a crossover cable. Sputnik. Oh, that's yet another one. That's not my book. Which is even better. Is there somebody in this room? Oh, is it a Mac? Okay. Would you allow me to rendezvous your computer? Okay. Thank you. Okay, now it's mounted the Apple file share, and you see the scroll bar. It is running, and yeah, it will now fill up your disk space. How much free space do you have? And now you can go to your Dropbox. And in there you will find a file, a dot file. which contains the bullshit data. Yeah, that's it. That's as easy as it gets. I'm gonna stop this now, but I'm glad that this got a little participation from the audience. And yeah, of course, there's a fix. You can go to the there's a preference file, library preferences com.applefileserver.plist. It's a property list, and there you can change the guest setting from true to false. This will disable it. Unfortunately, the default setting is otherwise, and you can't disable it in the system preferences. It would be great if the guest account would be disabled by default, and there was a possibility to enable it in the system preferences. This would be the ideal. Vulnerability number 5. I call it Mac injection because it's something the Mac kernel API allows. You can inject code into running programs at runtime and execute it. And this allows you to override arbitrary C functions in any running application at runtime. So at the first moment, this doesn't sound like a real security hole. Okay, it does, I'm glad, because it is. With Objective-C, it gets even more interesting. And to understand what's possible with Objective-C, let me make a small intermezzo about Objective-C. Categories. Categories is an Objective-C language feature. You can add new methods to existing classes at compile time. And this is something like subclassing without subclassing. It's very useful for developing applications. You usually use it to split large classes into multiple smaller files. But you can also use it to extend existing classes, like for example NSString, which is the string object, which is the string class in macOS 10 in Cocoa in the foundation framework. And let's take the example, you want to extend NSString to be able to deal with irregular expressions. So in your app, you create a category on NSString, which you call regexp. This is written in brackets after the class name. And in this category, you implement all methods you want to add to the mother class. And now all NSString classes are capable of regular expressions of these new methods you injected in this class. This is a normal language feature, and it's also regularly used in Cocoa apps. This has the advantage no subclassing and casting is necessary. You could, of course, also create a subclass of NSString, which is able to deal with regular expressions, but then you had to cast it and so on. And yeah, it's already told you can split up large classes into a number of smaller files. This is very nice, but on the Mac, it gets even cooler. We've seen we can do what we can do with Objective-C at compile time, but on macOS 10, you can also do this at runtime with any app you have running. You can inject categories into running applications at runtime, and this is quite something. It doesn't only let you override C functions, but also override existing classes in object-oriented programs. But it doesn't stop there. The Objective-C runtime library lets you also selectively replace one method with another. This is called method swizzling. So you can imagine you want to override a method in a class. You inject another method with the category, and then you replace the methods. You exchange the methods. So you overrode a complete a method in a running program. It can all be done at runtime. yeah, this is, I already told you. And the good thing is about it is you can also do this when you don't have the source code. Yesterday I played around with it a little, and I injected code into Safari, for example, which is closed source. And you can use it to patch the system as well, because the Finder, for example, runs under user privileges. It runs as your user, the instance of the Finder. So you can even patch the system at runtime. So you can make deep modifications in the system at runtime. Basically, you can do almost anything you want with any running app. And that's pretty tough, pretty hard stuff. So, yeah, implications on security. You don't get a free root shell immediately, but one can imagine it makes it easier for malware to patch the system in a malicious way, because when a virus or a worm or something has access to the Finder, it can inject code and change it in the Finder. You can change the behavior of the system in any unforeseen way. And no privileges are needed for this, to inject code into the Finder. So you can imagine a new kind of malware that works entirely with user privileges. You don't need root access. The malware doesn't need root. It can patch the system in a malicious way, and if it patches the Finder, it can even hide itself, which gives it some kind of a rootkit quality. And therefore, you could create something like a rootkit without root.
Question?
Yes, question.
What kind of privileges does this need to make the changes permanent? Because code that runs with user privileges, of course, can do anything the user can do. That's
Yes.
Nothing unusual. But how does it affect other users on the same system? Does it? Does it not? Does it need more privileges? And is this able to change anything that's run with escalated privileges?
Okay.
Non-user privileges?
Yeah, the question was whether I can also inject code into applications run by other users on the system. This is not possible. And you cannot inject code into applications run by root. This is only within your permissions. Of course, it's
There might be start button. If you use your features vulnerability, you put in start button.
yeah, of course. You can combine all these vulnerabilities that I'm mentioning here. You can always combine these and create even more evil or powerful malware.
So is this sort of like the web injection of Windows?
Yeah, this is basically something which you could also do with something like LD preload, but the difference is you can do it at runtime. Yes, I think this question was first.
What about set-UID binaries? If they have, for example, a race condition and take some time before getting to the root, can you inject some code before that happens?
Oh, I didn't try that, but I tried injecting code into a set UID application, because the effective user ID it runs as my user ID, but the effective user ID is root, or vice versa. But luckily this is not possible. You can't inject code into set UID applications, although you can start and quit them.
Question?
Yes, where? Yes.
If you don't have the source of the application, how do you know which class and method you can hide,
Yes.
if you can modify?
Yeah.
And
You have to know Objective-C is by design is a very open system. The class, the header files are in the binary. So there exists a tool called class dump, and you can use it to extract the header files, the whole header files of all classes and everything from the binary.
Can I, sorry, a question here
Yes.
as well. So if I understand you correctly, you're able to you're able to modify processes which are running with your user ID, right? And no other user IDs.
Yes.
And this, for me, doesn't seem at all like a bug. I mean, you own the process. You should be able to decide what it does or doesn't, and you're able to kill the process and restart
This
another
would be
process.
true. This would be true on an open source system.
Okay, understand. Okay, of course, you're able. I mean, you can able.
Let me give you an example
Okay.
of how you could do something which you couldn't do otherwise. Do you know? You all know the keychain, and the keychain keeps binary hashes. So it keeps a trusted database of trusted applications. So Safari, for example, can access the keychain without providing the keychain password. You don't have to provide the keychain password. So I could inject code into Safari that reads out your keychain passwords, and you would be able to do this without entering without knowing the keychain password.
Okay, fair enough. But then Safari is running with your user privileges, so it's actually your privileges to do this in the first place.
There's a Mac, and somebody did forgot to set to lock the screen. I can walk to it and have all his passwords within a second.
Oh, then it's an implementation problem
Yes.
with Safari, and,
Yes.
and not actually the Mac injection problem in itself that's manifesting itself.
It's multiple things coming together. You're right.
Okay.
You said before that the system preferences you set your helper application.
Yes.
Could this possibly also be used to fix the helper applications into doing something?
Yes, that's a good idea. No, but the system preference itself is not a setuid tool. It only communicates with the setuid helper.
But you could just invoke that.
Yes, you're free to try that.
Just another question about shared libraries.
Yes.
Can you even patch shared libraries which are loaded? As stuff in shared libraries?
To patch libraries, shared libraries, you would have to have write access to the library, to the directory where the libraries are.
No, in memory, just like
In memory.
the other thing.
I don't know. I didn't try
It's
that.
not featured.
But this is you can already do.
I don't know much about, but the idea would be a user process loading a shared library, and then a more privileged process using the same shared library, which is already in memory but patched.
I don't know. One would have to try that.
I have two remarks. Here, over here.
Yes.
First, regarding the question of how to find out what method to patch, the most convenient thing to do is use a little program that's called fscript anywhere. It kind of gives you a small talk-like language with which you can browse running applications and look into their object hierarchy. And another thing is, I'm not sure if you'll cover it later, the most convenient way to get your code running into other applications is to use the input manager mechanism. It's a plugin mechanism where every Cocoa application will look in a special folder and load all the plugins that are there. So if you drop something in there, it will get loaded next time any Cocoa application starts.
Yes, that's a valid remark.
I have here in the middle. I have a comment regarding the injection. I just want to reinforce the, if I understand it correctly, a huge risk in this injection technique is that it becomes very easy to intercept user interaction. Because, for example, typing in keyboards in your, typing in passwords in your web browser.
Yes.
And because there were several questions regarding the risks behind that, I think it's a very dangerous
Yeah, I think so too.
situation.
I think so too. Okay, but if you don't mind, I would like to go on with the lecture. We have not so much time left, and there's still a lot to cover. And I want to give you yeah, I want to give you the, I want you to be able to put questions later on. Vulnerability number 6. You can disguise executables as any other file type in the Finder. Now you can simply change the suffix from .app to, let's say, MP3 or PDF, and then you change the symbol so that you change the application symbol for the appropriate symbol for an MP3, and then it would not be a normal user would not be able to differentiate it, and there's unfortunately no fix known. And this has also been known to Apple for quite some time now. And yeah, I want to give a summary on what kind of vulnerabilities we have covered. First, the system preference privilege escalation, which is clearly simply an insecure default setting. But there's more to it. Together with Mac injection, you could intercept, you could inject code into system preferences that will call the setuid tool and so on. So the system preferences will be in the admin framework, which the system preferences uses internally, will still give us a lot of work, a lot of things to explore. And yeah, the second was bad permissions. Which is clearly a problem of the installers, but the system has to be better than the installers. So this is also something that can be fixed by Apple. Yeah, clear text passwords in swap. I don't think that encrypting swap in the next version is such a good solution. It would be easier to simply fix the admin framework, in my opinion. Yeah, personal file sharing, denial of service. This is also something which is only a secure, an insecure default setting. Yeah, and the Mac injection, yeah, we discussed it. It's something, the implications on security are not yet explored, I think. You can, perhaps next Congress, we will have a lot more local vulnerabilities using this Mac injection, together with the admin and security frameworks, which are closed source and have setuid root tools. And then, yeah, the disguised executables. There has been a proof of concept thing in April, and it was hidden as an MP3 file, and it was executing some code. And this is also something Apple didn't fix until now. But on the security side, there's one more thing. I want you to present the first macOS 10 worm, which is able to replicate itself. So I have a proof of concept worm here that can replicate itself. It can replicate itself via email, and so far it has no malicious routine or something, but I'm going to give you a small demo of it. I hope it works with this network here. Okay. So here you see this little PDF file, ppc shellcode.pdf, and of course it looks like a normal PDF, but it ain't. In fact, it's a Cocoa application, and when I double-click it, it will open the PDF file in preview, so you will not suspect anything. But it will also do something else. Here it wrote something into the syslog, and unfortunately we didn't hear the sound. Where's the angel here? We did test the sound in advance, because there we should have heard a sound. again. Okay, I'm going to try it again. And this is how it sounds when your Mac gets rooted. So the Mac laughs at you because you clicked on a PDF file. And this is clearly something which shouldn't be possible. And now this worm actually has a replication routine. It will send itself to all people in the address book. And I'm going to show you how this looks when you get such an email. One moment. Okay. Unfortunately, I have here some problems with the network, so I don't think I can show you the actual replication routine, but I'm going to show you a test I did in advance. So this is a typical mail from this worm. You'll get a PDF, and it also looks like a real PDF file. And when you drag it to the Finder, to the desktop, it didn't do it. Why doesn't it work now? Yeah, I'm going to save it manually, but normally this works. Ah, there it is. And then you double click on it, and So you see, this doesn't look very suspicious. When you get such an email, it looks like a real PDF file. The only thing you can't do is click on it. Then it will ask you if you want to save it to disk. But this is also something which occasionally happens when when you get a PDF from a Windows machine. So it will not make many people suspicious. So I see there's a question there. Sorry, could you wait for the microphone?
The question is whether this question is the same reason that usually mail up displays the PDFs right into the preview window inline. Yeah. Yeah, and well, it doesn't do it obviously with this. So this maybe could make you suspicious, and the same.
This could make you suspicious, but I think you can disable it.
I'm sure. Maybe you disabled it.
But if I got such a message, I would think it's from Outlook or something.
We all know it doesn't work all the
mail
time.
can't. Yeah, it's from Outlook, you know.
Of course.
Yeah, of course. When you investigate it further, you will see that it's not really a PDF file. Yeah, for example, if you type file information, for example, get info, it will tell you that it's an application. But who does this in advance before double clicking on it? Kind application, you see it. Yeah, but I don't think this is relevant for the normal user. Yes. It's a normal Cocoa application, package contents. And yeah, macOS 10. This is the actual binary that gets executed. And here in the resources, you will find the actual PDF as a resource that gets started. So the Cocoa application starts itself, then immediately opens the PDF file, which is here as a resource in this package, opens it with preview, and then executes some malicious code, and then it can replicate itself, which is implemented here. Yes?
Ein Command-Line-Name of OS 10 insecurity.pdf.app.
No, it's you can also on the shell it will say .pdf.
Okay.
Yes.
I have a question. How is this application transferred from the mail application to the desktop? I saw the line where before the application is this one something. Does it get extracted automatically?
Yes, this is done transparently. And the question was whether when you save it on the desktop, whether it will it's a compressed file. It's a zip file. And whether it will get extracted automatically. Yes, it will. It will be extracted transparently. You will not notice it. Also, when you send such a thing via mail, it will automatically zip it. So, because it's a directory, it will automatically zip it and without asking you. And you also can send this via iChat. You can drag this PDF to someone over iChat. At least it only works on Rendezvous. This works. For some reason over AIM it doesn't work. But over Rendezvous you can send this this application like this without zipping it first. I see there's a question over there. Or there.
Please wait for the microphone.
Do you know something about this underrun Trojan? I had that on my computer a week ago. Just because you said a proof of concept for the first try, and I had one last week. I downloaded some bullshit by file sharing and installed it, and
Yes.
it opened the backdoor for this Caracho client as a relay.
Mm-hmm.
You know something about that one? It installed some startup items in library startup.
No, the only thing I've heard of was the one in April. There was already a big story, for example, on Heise and so on. It was the Intego Security who first brought this, Intego Security company. But this one just didn't get that far, so that it had a that it could be would be self-replicating. So it had no replication engine. This has an SMTP engine built in. Can send it will look up all email addresses in the address book and send itself to them. So, and one can imagine that this virus actually has a chance, this worm has actually a chance to spread among Mac users.
Well, my question was, what happens if you open this manually with Acrobat Reader or Acrobat?
It will not work. You have to double click on it.
But what happens then?
Nothing.
Okay.
As far as I know, nothing. I don't use Acrobat, so. Yes.
And what happens if you use, say, Thunderbird? What will it show instead of the PDF icon?
I didn't try that, but I don't think it will be that easy. This is clearly an exploit for Apple Mail and macOS 10, which and I think most Mac users are using Apple Mail, and this is bad enough that it works with Apple Mail, I think.
Yes, excuse me, just a question. As far as I can see, this is just an application which opens a PDF file.
Yes.
And then perhaps sends itself through, let's call it, I don't know really macOS, but send it through AppleScript over iMail, or how is it called? So,
yes.
What's new about this, or which security flaw does this exploit?
The attack vector is known for quite some time, and Apple still hasn't fixed it. And by making this worm, by making a more more evil example of this worm, I want to put some load on Apple to fix this. And up to now, we didn't have a replication engine, which will be needed to, which is a real danger. If this thing gets in the wild, I don't want to know what happens. It doesn't have a doesn't have a malicious routine, but it will spread. I'm sure of it. Okay. Then, so we've seen quite some discouraging vulnerabilities, and I don't know how you feel about it, but I feel pretty bad about it, and now I want to show you the feelings I have when I see all these vulnerabilities. I ask myself, ugh. My name is Jojo and I'm a monkey. And yeah, that's about it. I have another slide which will tell you where you can find the slides afterwards. Demo source code will be available soon. I want to give Apple some time to think about it and perhaps release some security fixes. Thank you very much for your attention.